Good morning. I'm presently at the site of an RFI complaint in California, and unfortunately the complainant could not be here today, but he's kindly let us have access to his antenna by providing this cable. And we're now going to take a look and see what noise we see with a radar engineer's RFI locating receiver. You can see it's a pretty active. You have a number of sources in there. There's the signature. I've captured it in memory. And it's really hopping. So next, we're going to try to get a heading on it. Next, we're going to hook up the same receiver to this 4-element 2-meter Yagi, and we're going to try to get a heading on that noise. Okay, we're now hooking up the antenna. I walked away from the house a little bit to try and get out, away from automobiles, get out into the clear a little bit, and we'll just try to get a general heading on it. And then we'll switch antennas when we get in range up to 400 megahertz. So I'm going to change the frequency that I'm using to 148 megahertz for this antenna. And it's important to understand, it's key to understand that the signature does not change with the change in frequency. We're going to be looking for the same signature that we saw back at the house at 7 megahertz as we are at 2 meters with this antenna. Okay, now the peak of this noise is in this direction. Okay, now at this point I walked several hundred feet in the direction of the noise using the 2-meter beam. I'm now close enough, I'm in range to be using a 400 megahertz antenna made by the Radar Engineers Company. Once again, I've shifted my frequency of this receiver to 402 megahertz, which is right about where this one peaks. And we're now going to try to pinpoint the pole. At this point, we've walked several hundred more feet up the road in the direction of the noise, and I've approximately located the pole in question. This is the source pole that we've been looking for. What we're going to do now is stand equidistant between two poles. One is the suspect pole, and the other one is the pole just beyond it. Okay, now that's the suspect pole. First, I rotate the antenna to get maximum response to polarization. I then reduce the gain to just barely hear the noise. Once I've achieved maximum polarization, I carefully swing the beam around to the antenna on the other side. Clearly, the suspect antenna is the source of our problem. We've now gone back one pole in the other direction to repeat the same process to absolutely confirm that the suspect pole is the correct one. I'm now about equidistant between the pole on the other side and the suspect pole. You hear the noise here. There's our suspect pole. And there's the pole beyond it. Once again, the noise comes from that pole, our suspect pole, which we're now going to take a closer look and hopefully find the actual source of the noise. This is the final step of the process in trying to locate power line noise. We have, as you have already seen, located the pole, and at this point we're going to now be using something called an ultrasonic pinpointer. This is actually an ultrasonic device, as its name implies, and it's a microphone. As long as you have a clear shot between you and the arc causing the noise, you can pinpoint it quite precisely with one of these. Unfortunately today, this apparently will not be working too well for us because of some wind. Wind obviously can create a lot of noise for something like this, and what really is needed in this case would be something called the hot stick sniffer, which is really a device that only a power company can use because of safety reasons.